So the associative property. Now the associative property is something that only applies to addition and multiplication. So this is not going to apply to either division or subtraction. So just addition and multiplication. And what the associative property says is that if you take a number like 5 and you add it to a number like 3, that's the exact same thing as taking a number like 3 and adding it to a number like 5. So it's saying these two things are the same. A way that we can represent that, of course, is putting them equal to each other. So we can say 5 plus 3 is equal to 3 plus 5. And just like we said, this applies to addition and multiplication. So we can say the same thing with multiplication. We can say that 2 times x is going to be equal to x times 2. So the order doesn't matter with these, and specifically the order doesn't matter on either side of the symbol, with the plus symbol and with the multiplication symbol. So remember, this does not apply to subtraction and division. So here 5 plus 3 is 8. 2 times x, that's just going to be 2x. But we can check that this doesn't work with division and subtraction. So let's move these out of the way. So if we were to say 2 divided by 1, well, 2 divided by 1, is that going to be the exact same thing as 1 divided by 2? Two divided by 1, well, we said with the multiplicative identity, any number divided by 1, you're going to get out the exact same number. So 2 divided by 1, that is just going to be equal to 2. But 1 divided by 2, 1 divided by 2 is actually going to be 1/2, or 1 over 2. 1 divided by 2, that's the same thing as 1 over 2. And 1 over 2, that's like saying half of something. So if we have half of something, we're going to have way less than if we have 2 of something. So the associative property does not work with division. Likewise, if we were to replace these division symbols with subtraction symbols, well, 2 minus 1 and 1 minus 2, 2 minus 1 is going to give us 2 minus 1 will just be 1. Whereas 1 minus 2, if we start with one thing, and then we subtract 2, so we have to subtract 1, that gets us back to 0, then we subtract another 1, well, that's going to get us down to -1. So here, swapping these numbers around, the 2 and the 1, these do not give us the same answer. So again, associative property, remember, it only applies to the plus and to the multiplication symbol. One other thing we can do to show that real quick is with some boxes here. So if you remember, the area of a rectangle is equal to its length times its width. So if this rectangle here is equal to 3 times 5, is it going to have the exact same area as this rectangle over here that has an area of 5 times, where's my 3? Here it is. 5 times 3. Are these going to have the exact same area? Well, we can check this just by putting them on top of each other and seeing. Oh yeah, these do have the exact same area. So 3 times 5 is going to give the exact same area as 5 times 3. So this is one other way to show that the associative property holds for multiplication. And if we replace those multiplication signs with pluses, now this is going to be like, imagine that you were walking around the outside of this box. So we start here, and we're going to travel 3 in this direction, and then we're going to add on 5 more in this direction. So at the end, we'll have walked 3 plus 5, we'll have walked 8 units. We don't have any units up here, but we could imagine that that's 8 miles. If this is 3 miles and 5 miles, we will have walked 8 miles. Well, that's going to be the exact same as if we walked 5 miles and then 3 miles. So the associative property holds for addition as well. So remember, associative property, addition, and multiplication. All associative property is saying is that you can swap the numbers on either side of the plus and multiplication sign around, and you'll get the exact same answer. 3 plus 5 is 5 plus 3. 3 times 5 is 5 times 3.